What are eigenvalues and eigenvectors? Eigenvectors, when multiplied times A, will get the same eigenvector scaled by an eigenvalue. How do we solve for an eigenvalue? We will subtract lambda times x from both sides, factorize the x out, and we will just multiply by the identity matrix. Why is the reason why we can do this? It's because essentially it's just multiplying by 1. Now, what is an example of this? We can use the following formula to solve for an eigenvalues and an eigenvector. First, we will need to set the matrix A minus lambda times the identity matrix equals 0. We will need to distribute lambda across the identity matrix, which is lambda 0, 0, 1. Lambda equals to 0. Then we will get the matrix of 4 minus lambda, 2 minus 0, and 1 minus 0, and 3 minus lambda. But for here, we need to take the determinant. What's the formula for the determinant? It's AD times BC. This is only for square matrices. In this case, A and D will be this 2, and B and C will be this 2. So we will get 4 minus lambda times 3 minus lambda minus 2 times 1, which when distributed, we get 12 minus 4 lambda minus 3 lambda plus lambda squared minus 2 equals 0. And if we combine like terms, we will get lambda squared minus 7 lambda plus 10 equals 0. Here, we can use a quadratic formula or factorize. In this case, what two numbers, when multiplied, give us 10, and when added, give us 7? In this case, it's 5 and negative 2 equal to 0. Therefore, lambda, or the eigenvalue, is 5, and lambda also equals 2. What can we find for the eigenvectors, given the eigenvalues that we found? We can just replace lambda times 2 or 5, because the equation tells us that A minus lambda times the identity matrix, and we know that lambda is 5 and 2. Therefore, we can just distribute the 2 across the identity matrix, and then we can just subtract these two matrices, which will give us 2, 2, 1, 1 equals to 0. Therefore, what this tells us is that 2x plus 2y equals to 0. Therefore, x equals to negative y. And if we put it in parametric vector form, we know that x1 times 1 minus 1. And this is our eigenvector. In the second equation, we don't really need to do it because it's the same as the first equation.